All right, so, excuse me. So thankfully this stuff is actually very much like graphing cubic functions, so it's very similar to something that we've done. What's different about this formula than the formula we saw in 10.2? What's different? Do you see anything? The 3 is cubed, isn't it? Do you see that? I'm sorry. It's not the a that's being cubed. We have to be very specific about that. We are actually doing a cube root, so it's not a cubed. I would actually write the 3 down in there. It just probably wasn't able to be typed down in there. But a cube root, what is a cube root? Like if I asked you for the cube root of 8, what is the cube root of 8? 2. How do you know? Because 2 times 2 times 2 equals 8, or another way to say that is because 2 cubed equals 8, right? A squared is related to a square root, a cube is related to a cube root, okay? A is still vertical stretch, compress, reflect. B is still a horizontal stretch, compress, reflect. K is still a vertical translation, up or down. And H is still a horizontal translation, left or right. Some easy numbers to take the cube root of. The easiest number to take the cube root of is 1. What's the cube root of 1? Okay. I already asked about the cube root of 8. What would another number that would be easy to take a cube root of? 27. What would the next one be? Let's think about this. This is 1 cubed, 2 cubed, 3 cubed. The next one would be 4 cubed, right? Which is 64. And just for good measure, what would the next one be? 125. Because the cube root is 5. So far, so good? Now, I don't know why she has domain and range written twice, but do you remember cubic equations, what they looked like? Didn't they look like this? Do you remember that? Guess what cube root equations look like? That. They're just laying down. So, if that's a cubic and this is a cube root, something like that, what would you say is the domain of this? All real numbers, goes on forever and ever. What would you say is the range? Also all real numbers. Just like how cubics were both all real numbers, cube roots are also both all real numbers. Okay? End behavior, I'm not going to fill out this. We'll just fill it out when we look at a graph. All right? So, we're going to start with the mother function, the parent graph. First thing we have to do is find our point of inflection. How do you think I find my point of inflection? I'm actually going to write this up here. Remember, if your teacher writes something in all caps or highlights it or something that's kind of important, what do you think my inflection point is? Any guesses? Nope. For the parent graph, it'll be 0, 0, yes. But for all other graphs? HK. So the parent graph, it being 0, 0, is because H is 0 and K is 0. So my starting inflection point is 0, 0. Now, I'm going to put 0, 0 in the middle of my XY chart. That's what I did when I had square roots, right? Yeah? Okay, what do you think I'm going to do then? Fill in X values around. So let's start off with -1 and +1. Now with the square roots, one direction wouldn't work, right? Only the other direction would, because one direction would give us imaginary. Do we get imaginary numbers when we have a cube root? No, because you can take the cube root of negative numbers. Cube root of -1 is -1. Cube root of -8 is -2. Negatives aren't an issue with cube roots. So, if I plugged in -1, what's the cube root of -1? And what's the cube root of 1? Now, do I want to do 2 and -2? No, why not? You can't take the cube root nicely, can you? So if I did 1, the next number I'm going to want to do is 8. So let's do 8 and -8. What's the cube root of -8? -2. And the cube root of +8? Now, do you remember with cubics how we had the 3 points in the middle and then the 2 outside? We're going to have the same thing going on here. Excuse me. So -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So if I turn it on its side, that's what my graph looks like. So what's my domain? All real numbers. What's my range? End behavior. This first statement, is it asking about the right or the left? The right. What's going on the right? It's going positive. It's going up. On the left, it's going down. So that would be negative infinity. Pretty easy? Yeah? Okay. Let's look at the next one. Now the next one already has the XY chart filled out for us. Interesting. First off, what's the inflection point? -2, -4. And you see that right in the middle. Why did we choose those X values? Well, let's look at these numbers. Remember the 1, 8, 27, 64, etc.? From this X value, 1 away gives me those two numbers. 8 away gives me those numbers. Does that make sense? So if I went 1 away, I get -1 and -3. And then if I go 8 away, 8 below would be -10, and 8 above would be +6. That's how we get our nice X values that'll give us decent cube roots. So let's describe this. This is the same as the parent function, but what's going on? What does the 2 mean? We have a shift. How? 2 to the left. And the 4 means we have a shift. What? 4 down. So if my inflection point was at 0, 0, it has now been shifted 2 to the left and 4 down. End behavior, what's going on the right? Up. And on the left, down. What's my domain and range? All real numbers. Okay. Questions on that one? All right, let's look at the next one. What's my inflection point? 0, 3. So far, so good? So, let's see. Let's describe it. What does the 1/2 mean? Is that A or B? It's A, so we have a vertical A vertical what? Compression of what? Of 1/2. And what else do we have going on? Shift how? 3 up. Excuse me. All right, so what other x value should I choose? -1 and 1, because again, we want to do 1 away, and then we'll want to do 8 away, right? So 8 away would be -8 and +8. So let's see. Cube root of -1 is -1. -1 times 1/2 is -1/2. I'm just going to go ahead and go with it because with cube roots it's just a pain to try and keep finding numbers that'll multiply nicely. So -1/2 plus 3 would be +2.5 or 2.5. -8, cube root of -8 is -2 times 1/2 is -1 plus 3 is it's 2, right? Keep checking on me. All right, cube root of 1 is 1 times 1/2 is 1/2 plus 3 is 3.5 or 3.5. And again, you can do this on your calculator if you want. Cube root of 8 is 2 times 1/2 is 1 plus 3, there's by 4. All right, -8, 2, -1, 2.5, 0, 3, 1, 3.5, and 8, 4. So we had a vertical compression, which means we've got a really flattish one. It's really kind of a skinny, a wide and skinny graph. You see how it was taller here and now it's been kind of squished a bit. It's been squished by half. All right, end behavior, what's going on the right? It's going up. On the left, it's going down. Domain and range? All real numbers. Because it goes forever to the left, forever to the right, that's my domain. Forever up, forever down, that's my range. Okay? All right, turn the page. All right, I want you to try these two. Okay? I think you have enough now that I want to give you a minute for you to try these two. All right, what's my inflection point here? -2, comma what? 0. Let's talk about our description. What have I got? What is this number representing? Thank you. Thank you. What is this number representing? A horizontal what? Stretch. And h being -2 is a shift how? 2 to the left. So in the middle, I have -2 and 0, right? If I know nothing else, I know my domain and my range, right? Get yourself a couple points there. Now let's go one outside. So let's see, -3 and -1. -3 plus 2, I think I'm going to go to my calculator for this. Just because it's going to get kind of ugly. Now your calculator does have a cube root button. Sometimes it actually looks like a cube root. Other times it looks like this right here. Can you see what that is? It says X radical. So what I have to do is if I'm doing a cube root, I have to press a 3 and then shift and that button. And so if it says 3x radical, that's calculating a cube root. Okay? So the cube root, I'm going to call that 0.5. Are you okay with that? I'm going to open some parentheses, 0.5, and then another set of parentheses, negative 3 plus 2. Close both sets of parentheses. And I have negative 0.8. We'll just go with that right now. Now if I arrow back, I need to change the negative 3 to a negative 1. And that gives me positive 0.8. What should the next numbers that I use be? These were 1 away. What's the next ones? 8 away. So that would be, no, it's not 8 away from here. It's 8 away from your inflection point. So negative 10 and what? 6. So I'm going to go in and change the negative 1 to a negative 10. Negative 1.6 is what I get. And change the negative 10 to a positive 6. And I get positive 1.6. Now, why did I get this almost like mirror reflection of the y values? That's going to happen when your k value is 0. When your k value is not 0, you're not going to get that pattern. Okay? All right, negative 10, negative 1.6 would be around there. Negative 3. Oh, hang on. What did I do wrong there? What? Yeah. I went to negative 20. It's counting by 2's, isn't it? So, negative 10, negative 1.6 would be right about there because we're counting by 2's. Negative 3 would be right here, and negative 0.8. Negative 2, 0. Negative 1, positive 0.8. And 6, 1.6. Now, right now, I'm okay with you just using those decimal numbers. Just makes life a little bit easier. Just go to your calculator. And behavior, what's going on the right? Up, left, down. Okay? All right, next one. We've only got one thing going on. We've got a negative 3. What is that? Is that A or B? It's B, but it's only kind of B. Because negative 3 really represents 1 over negative 1/3, right? We have to take the reciprocal to get our B value. So we actually have a horizontal reflection and compression of 1/3. So, what is my inflection point? 0, 0. Negative 1 and 1 would be my next ones. Negative 3 times negative 1 is 3. Cube root of 3. If I come back here, cube root of 3 is 1.44. Cube root of negative 3 is negative 1.44, which is what I get on that side. Now, look at my graph. If I were to go to negative 8 and positive 8, they wouldn't fit on my graph, would they? Right now I have negative 1, 1.44. I have 0, 0, and I have 1, negative 1.44. What would be a good number to show me what's going on here? How about we just pick 4 and negative 4 so we can see where it is at the edge of the graph. So negative 4 and 4. If I plug in negative 4, I have the cube root of what? Negative 3 times negative 4 is 12. And I get 2.28, which I'll call 2.3. Negative 3 times positive 4 would be negative 12. And I get negative 2.3. So that'll just show me what's going on the edge of my graph. So negative 4, 2.3, and positive 4, negative 2.3. What's my domain and range? All real numbers. And behavior, what's going on the right? Down. On the left? Up. Okay. All right, last two, we're going to write an equation given the parent function. Now, with these ones, what I want you to look at very carefully is the equation that's given to you. If I look at this one of my letters is missing. What letter is missing? B. So I only need to find A, H, and K. Over here, what letter is missing? A. So I only need to find B, H, and K. All right? So H and K should be easy. Why? It's my inflection point, right? So what's my inflection point here? -1, -3. There's my HK. Now, how do you think I'm going to find A? I have to do the little box. So again, the original parent function right here, I have my box. What are the dimensions of the box? 1 by 1. This one right here, dimensions are 1 by 3. So what do you think A is? 3. It's a vertical change, right? Not a horizontal change. Now, last thing I need to check is the end behavior the same as the parent function? Right side's going down, right side's going up. So that means there was a reflection. Only one of these letters can represent a reflection. Which one represents a reflection? So that has to be a -3. So if I plug this in, A equals -3. So let's see, I have f of x equals -3 times the cube root of x what? Plus 1 minus 3. Pretty easy. All right, last one. Let's see. What's my vertex here? What's my point of inflection? What's my HK? 4, 1. And if I make the box, be careful with the dimensions here, because the boxes are not counting by ones. What are they counting by? A half. So this is 1 tall, but it's 1/2 wide. Do you get that? Because this is 1, because it's counting by 1/2. So what is B? 1/2. Is B going to be positive or negative? Positive. How do you know? End behavior is the same. So let's fill this one in. G of x equals the cube root of, if this is B, what is 1 over B? What's 1 over 1/2? 1 over 1/2. My calculator doesn't want to do it. 1 over 1/2 is 2. It's the reciprocal of it. So I have 2 parentheses, x minus 4, and then plus 1. Okay. All right, so your homework is right here. These problems, I want you to make a graph. So feel free to come up and grab a piece of graph paper for your homework. I will put the textbook page on Google Classroom for you.